Acid, bases and salt. So today we will be doing the last part of this chapter, that's preparation of salts. Now, what are the different methods of preparation of salts? What do you think? Pause the video and write down what you think can be the possible ways of preparing a salt. Now, as per our Icse syllabus, we will be concerned only with the preparation of normal salts. We will be deciding on the method of preparation on two things, on the criteria of the solubility of salts in water. So we will divide the methods of preparation into two subparts. The first one, preparation of soluble salts, and the second one, preparation of insoluble salts. With the preparation of soluble salts, there are various methods of preparation. We have summarized all the methods and the type of salts or the particular salts which can be prepared by these methods. The first one is direct combination. So it's also called synthesis. We prepare salts like ferric chloride and aluminium chloride by it. We will be discussing in details about these methods of preparation later on. The next method, simple displacement. We use this method for preparation of soluble salts of magnesium, aluminium, zinc, iron. Or we can say the Mazy group of salts. So MAZI for iron. So that's a way of remembering the salts prepared. Neutralization of alkali. So by the neutralization, that's by the reaction between an acid and base to produce salt and water. Here the base will be specifically an alkali, and the method of preparation is actually called titration. So we prepare salts of sodium, potassium and ammonium by this method. The fourth method, neutralization of an insoluble base. Again here it's a reaction between an acid and base, but here the base is insoluble in water. So salts like copper sulfate, zinc sulfate, copper nitrate, lead nitrate are prepared by this method. Even the chlorides can be prepared by this method. Action of dilute acid on carbonates and bicarbonates. So a reaction with metal carbonates and dilute acid will give us certain salts, and we use this method for preparing salts like again copper sulfate, zinc nitrate, copper chloride, sodium sulfate. So if we are asked to prepare salt from a carbonate, we use this method, or a bicarbonate, we use this method. So now let's go into a detailed analysis of all the methods of preparation. So the first method which we will be discussing today is direct combination. In direct combination, what we are doing? We are reacting a metal with a non-metal to produce salt. Now a metal plus non-metal gives us salt. So the salt which we prepare is ferric chloride. So iron, we take iron filings, heated iron filings, plus a chlorine gas over it, dry chlorine gas over it, and we end up getting ferric chloride salt. The ferric chloride usually formed in form of vapors and condensed and collected. Even aluminium reacts with chlorine to form aluminium chloride. Now a question usually comes to our mind. How is it possible that when iron reacted with chlorine, we got ferric chloride and not ferrous chloride? How we will understand when it will be ferrous and when it will be ferric? Usually whenever iron reacts with a strong oxidizing agent like chlorine, you get the ferric salts. If it does not react with strong oxidizing agents, like when iron reacts with dilute acids like hydrochloric acid or sulfuric acid, you always end up with the ferrous salt. So as per your syllabus, you will see this is very clear. Whenever there is a strong oxidizing agent and iron reacting with it, it's ferric. The next method is simple displacement. So what is this method all about? We take a metal, treat it with dilute acid, and we get salt plus hydrogen gas. This method, this set of reactions you have already encountered a number of times in the last few years of studying chemistry. So the reactions as such are not that difficult. So how does it happen? Zinc reacts with hydrochloric acid, giving us zinc chloride and hydrogen. Iron reacts with hydrochloric acid, giving us ferrous chloride and hydrogen. Please remember, all the acids which we are using here are dilute hydrochloric acids, or dilute acid rather. Even iron reacts with sulfuric acid, giving us ferrous sulfate plus hydrogen. So what do you think? What will happen if zinc reacts with sulfuric acid? Try and write down the products on your own. Zinc reacting with dilute sulfuric acid, magnesium reacting with dilute hydrochloric acid, and see what do you think will be the salt produced in that case. The next method which we will talk about is neutralization reaction. A neutralization reaction is a reaction in which an acid reacts with a base to form salt and water. That's basically how we define a neutralization reaction. And the main reaction in the neutralization reaction is that of the hydrogen ions of the acid reacting with the hydroxyl ions of the base, giving you water. The other ions are usually called the spectator ions. So here what we are doing is this method, which the procedure by which we carry out this neutralization, that procedure is called titration. We use a burette and a pipette and a conical flux to carry it out. We don't need the experimental details and the apparatus required. That's not in a syllabus. Our syllabus concerns only with the reactions and the reactants and products formed. So what is the first example here? This base here is actually an alkali, a water soluble base. The general reaction is acid plus base, salt plus water, so it's easier to memorize. So we won't write alkali there, but we should remember always, whenever we are talking about titration, we are talking about an alkali being used. We cannot use an insoluble base in titration. So the first reaction, hydrochloric acid reacts with sodium hydroxide, produces sodium chloride and water. So that's one of the ways for preparing sodium chloride. Ammonium hydroxide reacts with sulfuric acid, gives us ammonium sulfate and water. The next set of reaction we have hydrochloric acid reacting with ammonium hydroxide and giving us ammonium chloride and water. Now neutralization of an insoluble base. So now we are using the insoluble bases to prepare the salts. The reaction is same again, acid plus base gives salt plus water. Now memorizing reactions are the biggest challenge which a student faces as per concerned with this subject. And the moment we started preparation of salts, you see it's a lot of reactions which is coming your way. The easiest thing is to remember the general equation. That's an acid plus base gives salt plus water. And then you carry on with the reactants and try to predict the product. So if you have copper oxide reacting with sulfuric acid. So copper oxide is a base. Sulfuric acid is an acid. So what's the product to be formed? A salt and water. Now who will form the salt? It's always we have studied during the definition of salts. It's the basic radical of a base and the acidic radical of an acid, which combines together gives you the salt. So if you see the first reaction, copper oxide. Who is the basic radical here? Copper Cu plus 2. Sulfuric acid. Who is the acid radical here? Sulfate SO4 2 minus. So copper and sulfate. So your salt becomes copper sulfate. So Cu plus 2 SO4 2 minus. You know the crisscross method of writing formulas. So you can write the correct formula CuSO4, and the other product in neutralization is always water. How the water is formed? The hydrogen ion of the acid is reacting with the oxide ion of the base, here giving you water. So let's go into the next one. PbO, lead monoxide plus nitric acid gives us PbNO3 whole 2 plus H2O. This reaction is a very important reaction in your syllabus. This question comes very often in the board exams, or rather they tell you to prepare lead salts, and whenever you have to prepare lead salts, as there are no other ways out, so you have to go via this method, especially an insoluble lead salt from another insoluble lead salt. If you are asked to prepare, this is one of the reactions which will always come there. PbO plus HNO3 gives PbNO3 whole 2 plus H2O. Mark it as a very important reaction. Next one, lead hydroxide. PbOH whole 2 plus nitric acid gives us lead nitrate plus water. And then we have copper oxide plus nitric acid giving us copper nitrate plus water. This is also quite important as per your syllabus. Action of dilute acid on carbonates and bicarbonates. So a metal carbonate or a metal bicarbonate can react with a dilute acid and give you salt plus water plus carbon dioxide. Please make a note, it's always dilute acid and not a concentrated acid here. So it gives us salt plus water plus carbon dioxide. That's the product. So if you ever have a carbonate or bicarbonate salt and a reaction with acid, carbon dioxide gas is always evolved. And this gas is a colorless, odorless gas which turns lime water milky. So this point will be required in writing your observations. Now the first reaction is again one of the important reactions as per your board syllabus. It's very common in the ICSE questions. You will see past year questions, this reaction comes. So lead carbonate reacts with nitric acid, gives us lead nitrate plus water plus carbon dioxide. Zinc carbonate reacts with nitric acid, gives us zinc nitrate plus water plus carbon dioxide. Potassium bicarbonate, so now we see a metal bicarbonate reacting, gives us hydrochloric acid, reacts with hydrochloric acid and produces potassium chloride plus water plus carbon dioxide. Okay. So some more reactions with metal carbonates or bicarbonates. Copper carbonate plus sulfuric acid gives us copper sulfate plus water plus carbon dioxide. Copper carbonate plus hydrochloric acid gives us copper chloride plus water plus carbon dioxide. This copper carbonate plus sulfuric acid is also a board question. Now we have completed with the preparation of soluble salts, and we will move into preparation of insoluble salts. Some of the salts are insoluble in water. We saw it in the last class when we were discussing about solubility of salts. Now how to prepare these salts? There are usually two methods of preparation of insoluble salts. The first one, direct combination, and the next one, precipitation reaction. A precipitation reaction is usually a double decomposition reaction. Now direct combination reaction is used for preparing the insoluble sulfides. You know, all sulfides are insoluble except that of sodium, potassium and ammonium. And precipitation reaction is used for preparing the rest of the insoluble salt. So you can prepare any insoluble salt by this method. Especially in your syllabus, it's the carbonates and lead chloride, lead sulfate, barium sulfate, calcium sulfate. As per your syllabus, these are the important salts which comes under the precipitation method. Now we start with the first method of preparation of insoluble salts, that's synthesis or direct combination. Here a metal reacts with a non-metal to produce salt. So the metal provides the basic radical for the salt and non-metal provides the acidic radical required for the salt. We usually prepare the metal sulfides by this method. So iron plus sulfur gives us ferrous sulfide, so FeS, a black solid. Zinc plus sulfur gives us zinc sulfide, a dirty white solid. Lead plus sulfur gives us lead sulfide, again a black solid. The last method which we have come in the preparation of salts now is double decomposition or precipitation. So you know a double decomposition reaction involves nothing but an exchange of the basic and the acidic radicals between two compounds. So AB here reacts with CD, gives you AD plus CB. So there has been an exchange of the basic and acidic radicals. So AB, A is the basic radical, B is the acidic radical. CD, C is the basic radical, D is the acidic radical. So when they exchange the basic and acidic radicals, in place of B, D comes in place. So it forms AD, and in place of D, B occupies the place. You get CB. How do we prepare? We take two soluble salts. So AB is a soluble salt. CD is another soluble salt. We prepare the aqueous solutions and then we mix them. When we mix them, we get one of it as an insoluble salt. So let's assume here AD is the insoluble salt and CB, the other salt, will be a soluble salt. Now lead nitrate reacts with sodium chloride, gives you lead chloride plus sodium nitrate. So PbNO3 whole 2 plus 2NaCl gives you PbCl2 plus 2NaNO3. Don't try to memorize these equations with the balancing. You will tax your brain and you will make the subject very distasteful. Better way, just remember when a double decomposition reaction or a precipitation reaction is occurring, I have to just exchange the radicals with the correct valencies. You will automatically get your answers. Calcium chloride reacts with sodium carbonate, gives you calcium carbonate and sodium chloride. Calcium carbonate is the insoluble salt which has been formed. So you will get a precipitate of calcium carbonate, a white precipitate. Lead chloride is also a white precipitate and it's an insoluble salt. So lead chloride though is soluble in hot water, but it's insoluble in cold water. The last set which we have is zinc sulfate reacting with ammonium carbonate, gives us zinc carbonate and ammonium sulfate. Lead nitrate reacts with sodium sulfate, gives us lead sulfate plus sodium nitrate. Barium chloride reacts with sodium sulfate, gives us barium sulfate plus sodium chloride. Here zinc carbonate is the insoluble salt, lead sulfate is another insoluble salt, and barium sulfate is an insoluble salt. All of these salts will give you a white precipitate. Okay, all of them are white salts. You know, sodium, potassium, ammonium, zinc, lead, barium, calcium, magnesium, all of them form white salts only. They don't form any other colored salts. Usually, if not, the acid radical in that salt is colored. If the acid radical is a colored radical, then only it will be a colored salt. Otherwise, these salts form colorless salts or white salt, rather white salts, not colorless, white salts. So here we finish this chapter, acid, bases and salts, and now it's time to solve the ICSE questions and prepare yourself for the board exam.